Welcome back. In this lecture, we will continue the determination process for water content, the last process which remained, and it is very important from numerical as point. Okay, it is a famous one, Pycnometer. This is for water content. Pycnometer can be used for other purpose also, such as specific gravity. We will look into that in this lecture only. We will study pycnometer exclusively for determining the index properties, whatever it may be. So, what is a pycnometer? Look, it is a bottle which looks something like that. It is a circular opening and a conical top and a cylindrical jar. This bottle is pycnometer. The diameter of this is 6 mm. Opening, it has 6 mm opening, and the volume of the bottle is 900 ml milliliter. 1 ml equal to 10 to the power minus 3 liter. So, and circular opening of 6 mm dia. Okay, this is about what is pycnometer. Now, as we are looking into how to calculate the water content, so water content using pycnometer. The very first thing you should know is if water content is to be determined, then specific gravity of that soil must be known to perform this experiment. Okay, why it is required, I will tell you. You will look that how without a specific gravity known we cannot determine the water content if we use the pycnometer bottle. The second important one is that it is the second quickest method, as it gives result within 10 to 20 sorry so as it gives results within 10 to 20 minutes, but the accuracy is very less. It is less accurate, but it is the quickest method. Okay, pycnometer method. It is second quickest method, as first quickest method is the calcium carbide method, CaC2, or moisture tester. Procedure. Let weight of empty pycnometer is W1. Moist soil sample is placed in the pycnometer, for which the water content is to be determined. Let its weight equals W2. Now, the remaining volume of the pycnometer is filled with water. Let the weight be W3. Now, pycnometer is exclusively filled with water. Let its weight be W4. So there are 4 weights in which we have to interpolate the results, and we have to derive, or we have to find a results for the water content. What will be water content? So there are 4 jars actually. Look, here is an empty pycnometer bottle, W1. Now the pycnometer, empty pycnometer, is being filled by moist soil, is W2. Moist soil in sense the soil will be having solid and it will be having water, and it is free spaces, it is W2. Now again the free spaces which is in remained in pycnometer bottle is filled completely with water, and that weight of jar, or that weight of the pycnometer setup, is W3. Means it is solid only and complete water. Okay, this weight is W3. Now pycnometer is separately filled completely with water and it's weighed water content. Now, so what we require to determine water content, we need weight of water at second stage and weight of solid. What is weight of solid at second stage itself? So how we do this? Look, what will be weight of water at stage 2? It will be weight of the complete jar in second stage, W2, minus weight of the empty jar, W1, minus weight of solid. Yes or not? Weight of solid that is there, that weight should be reduced to get weight of water of stage 2. Now, and what is weight of solid? Weight of solid is weight of solid equals W2. So water content will be W2 minus W1 minus WS. Oh, sorry, this is WS over WS. Now, the only unknown is weight of solid. What is weight of solid? So this process is basically to determine weight of solid, and once we determine the weight of solid, we get the water content. Okay, so let's do it. How do we find weight of solid? I am making some, look, this bottle is completely filled with water, so we need which water? We need this water, weight of this water. Yes or not? We need weight of this water. Okay, let this be water B, this portion be water B, this portion. This is B. Okay, so this is also water, so we need basically this water, and this is also completely filled with water. Now we require to determine the weight of solid. So how we do this? Let's do it. I've said we must have the specific gravity in this case. So true specific gravity GS tends to gamma solid over gamma W. What is gamma solid? Weight of solid over volume of solid over gamma W. So from this we get GS gamma W equals weight of solid over volume of solid. Yes or not? So hence volume of solid, what will be volume of solid? Weight of solid over GS gamma W. Yes or not? It will be volume of solid. Now, since we have got volume of solid, but we do not know density na, hence we cannot calculate the weight. So we have to calculate it alternatively. And what is that alternative method is? We will calculate the weight of water. Weight of water. So weight of water B, that is volume of which equals the volume of solid. Yes or not? Vs equal to volume of water B. The same volume is being placed, water B. If it is true, then what will be weight of water B? What will be it? It will be volume of water B times gamma W. We know it. What is gamma W? 9.81. You know, everyone knows. Hence, what it will goes like Ws upon G S gamma W into gamma W, which will be Ws over Gs. This is weight of water B. Okay, let's move to next page. Hence, what will be the weight of fourth jar? W4 can be written as the complete weight as weight of jar at third stage minus weight of solid in third stage. Not third stage, weight of solid is constant all over the experiment, throughout the experiment. If you have reduced this, what we required? We required the weight of water. Okay, only the weight of water. We required weight of water. Then if we reduce this portion, this weight, then we have to add another weight which we have determined, that weight of water B. What we got? We got Ws over Gs. Yes or not? Means this is weight of water equivalent to volume of solid Vs. We have added this weight. Now we got an equation, and by solving this equation we will find out the weight of solid. It will goes like, if you will simplify W4 if we simplify this equation, then we will end up with the equation. Look, W3 minus W4 must equals Ws minus, I can write like this, Ws over G. W3 minus W4, Ws G minus 1 over G. Hence, weight of solid we got W3 minus W4 over G minus 1 over G. Now plug in this weight of solid in that very first equation which we have written to what is the water content, and find out the value of water content. This is the complete method. Okay, so the final equation what we get on simplification is, final equation we get on simplification is, look, water content equals W2 minus, this is the complete term, minus 1 into 100. This is one term, this is one term. Okay, this is the value which we have got. This is the water content by Pycnometer method. Now, so the first index property, water content. What is water content and the methods to derive it has been completed. Now let's move towards the second index property which we have to study is now second index property. What is that? Let us go with specific gravity, because specific gravity is also determined using Pycnometer method. Okay, so we will discuss in this slide. To determine the water content we require, anyhow we require specific gravity. So obviously while conducting Pycnometer method, we combiningly do the both experiments. To first we do experiment to determine the specific gravity, then we conduct the same experiment to determine the moisture content of the moist soil. So second index property is specific gravity of soil. Everyone know, I think I have covered this definition while studying the basic parameters of soil. So it will be very easy to understand actually what is specific gravity. I will recall here, specific gravity G S is weight of solid provided water is at temperature of 4 degrees centigrade, because at 4 degrees centigrade the density of water is maximum. The curve goes like something. This is a curve with density and rho and the temperature. So like compaction curve. Okay, at this temperature value, that is approximately 4 degrees centigrade, the density goes maximum. Hence we have used the 4 degrees centigrade value here. So this is the specific gravity. Then how we will determine it using Pycnometer bottle? Let's do it. So using Pycnometer, specific gravity is determined. All the procedures are same as the first method, but the only difference is in first method we required to find the water content. In water content method, hence we have used the such a soil which have moisture content, some amount of moisture. But in this method, what we will use? We will use dry soil. Instead of using the moist soil, we will go to use the dry soil. So let's continue. So I will write it down, that the procedure is completely similar as to determine water content. The only difference is, instead of using moist soil, we use dry soil. At stage 2, stage 2, the second stage, when we fill the soil in the empty Pycnometer bottle. So at this stage, instead of using the moist soil, we will use dry soil here. So let's begin. So let me draw some Pycnometers jar. Let this be first one, first stage, first. Let weight be W1, empty bottle, empty one. Now this is the second pycnometer bottle having dry soil, dry soil. So hence this is what it will be air. Let this be the weight of solid and this is the volume of solid, and this weight at this stage is W2. Now the third pycnometer bottle will be the same procedure. What we have done in that method is we have filled the remaining empty water, remaining empty portion, remaining free spaces in pycnometer water completely with water. Hence here the remaining portion is this portion. We will do the same dry soil, and what we will do, we will completely fill it again with the water. Okay, we have filled this completely with water. So, and let this weight at this stage be W3. Look, the volume of solid and weight of solid always remains constant because we have made an assumption in very first initial lectures of this series that solids are considered to be incompressible in engineering aspect of soil mechanics. So here it will be the same. Now in the fourth chart, what we have used to do, okay. So what will be specific gravity? Look, specific gravity will be weight of solid, this Ws divided by this weight of water, means weight of water B of same volume. So Gs will be weight of solid at stage 2 divided over weight of water B. Now, so what is weight of solid at stage 2? What is it? It is simply because since we have used the dry soil, how do you get dry soil? You have to conduct an oven dry experiment prior to determining the specific gravity. So look, all those experiments are related in a series manner. The parameters you have to determine, all those experiments are related anyhow. Okay, so this is the link, this is the concept which you have to understand, that before determining the specific gravity using pycnometer method, I have to conduct oven dry, then I have to conduct again pycnometer to determine the water content. Yes or not? All those methods are linked. So what is this weight of solid at second stage? Since the soil used is dry one, hence it will be simply W2 weight of second jar minus weight of empty jar, because if we reduce this one, the only weight remained is weight of solid at second stage. Now we have to determine the weight of water of B, weight of water B. For that, weight of water B. Now the only required is weight of water B. Think about how you can find out weight of water B. It's a simple logical deductions. Weight of water B. Okay. Look. First I need what is weight of water A. Weight of water A. That is in jar number 3. It will be weight of jar number 3 minus weight of solid. And what is this? It will be simply you have to deduct weight of jar number 2. W3 minus W2 will be weight of water A. Now again, so what will be weight of water in jar number 4? In jar number 4, means weight of water A plus B. What will be it? Just weight of jar number 4 reduced weight of jar number 1, empty jar. We get the both weights. Now weight of water B will be weight of water A plus B minus weight of water A or not? Weight of water A. So we have find out that what is this? W3 minus W2 again reduced with W4 minus W1. On simplification, W3 minus W2 minus W4 plus W1 or not? This is what we got. So how you will get the GS value? GS will be W2 minus W1 divided over the expressions W4 minus W1 minus W3 minus W2. This will be specific gravity. Sorry, I think I have made a mistake here. It's a big mistake actually. It should be reversed. This I have written in wrong order. Just make a change. It will be W4 minus determine this water content in laboratory only. You can determine simply by oven drying process, or for pycnometer first you have to conduct a first you have to oven dry soil, then you have to find out specific gravity, then you have to find out water content. So there is a 3-stage process, but it's quick because oven dry you will keep for 2 to 3 minutes, the soil will be dry, all the water get evaporated. Yes or not? Well, thank you. I will end up with this one, and in next lecture video we will start the next index property, which is unit weights. Okay, and we will look into how to process, how that are available to determine, how to determine it, and what are the differences between all those processes. Thank you.